One quick note on the asymptotes of a hyperbola. We looked at the asymptotes of a hyperbola that opened horizontally. Let's look at the asymptotes of a hyperbola that open vertically, like this. So the distance from the center to the vertex, that's A. And remember, there's this other distance, B, that sort of forms a right triangle with a focal distance C. Right, here's your focal distance. And we saw that these asymptotes are determined by just y equals plus or minus this vertical distance divided by this horizontal distance. Well, we have to be a little careful to put a vertical distance in the numerator for our slope here, and a horizontal distance in the denominator for this slope, right? Slope is rise over run, or change in y over change in x. And so you have to have a vertical distance in the numerator. So we don't want to put b in the numerator here, right? This version of the equation of the asymptotes, that's for when the hyperbola opens horizontally. The equation for this hyperbola is y squared over a squared minus x squared over b squared equals 1. And so this a is a vertical distance. And so when your hyperbola is opening vertically, it's a that goes in the numerator of this slope and not b. Since b is a horizontal distance, b goes in the denominator of this slope. Okay, so the form for the asymptotes of a hyperbola depends a little bit on whether the hyperbola opens vertically or horizontally. You just have to remember that the vertical distance in this little right triangle goes in the numerator, whether it's a or b, and the horizontal distance goes in the denominator, whether the horizontal distance is a or b.